Hello, this is part 2 of the Unit 2A Algebra 2 review. With starting on number 12, this is a standard form polynomial right now. That's standard form because it is in decreasing degree order, which is the decreasing exponent. And that the degree, which is the highest exponent that is in here, is 5, which just to talk about the end behavior. Since the degree is 5, that means it has an odd degree. And the leading coefficient, that's the coefficient that's in front of that term with the degree. It's a 1, since there's nothing written there, which means that has a positive leading coefficient. And the constant, that's the number that doesn't have an x on it, is going to be a negative 8. So the degree, the end behavior, sorry, that means it's going to have has an odd degree, and it's a positive leading coefficient, so it's going to increase in general. There's going to be stuff that goes on in the middle, but this is the shape that it's going to have, which means that as x goes to negative infinity, so as x is going this way, left on the graph, y is going downwards. So y is going to negative infinity, or p of x in this case. And as x is going right to positive infinity, as the x values are increasing, the y values are also increasing. So that's how we would describe or look at the end behavior. In number 13, this is given to us in factored form. So we can calculate the degree by adding up all of the exponents. 2 plus 2 plus 3 plus 1. So 2 plus 2 plus 3 plus 1 is going to give us 8 is the degree. So this is going to have even degree. And then the leading coefficient is going to come from multiplying negative 3, which is found right here, the 1 that's in front of this x squared, the 1 cubed, and I'm just stating these that way if it's ever a different number you realize it, and then the 2, which has an exponent of 1. So this is going to be a negative 6, which means it has a negative leading coefficient. The constant we can calculate by technically this factor of negative 3x squared. This is a negative 3x plus 0 squared. So that means we're going to multiply all of those numbers, that come from multiplying out the polynomial to get the standard form. Really, this is going to be 0 because we are multiplying by a 0, but just in case that factor wasn't ever there, this is how you would find it. So 0 is going to be the constant. And then because this is in standard or factored form right now, we can see that the x-intercepts are where each factor is equal to 0. So on the first factor, negative 3x squared equals 0 at 0. And then we have negative 2, and then we have positive 3, and then we're going to have a positive 1/2 from where 2x minus 1 equals 0. And we can find that by simplifying it so that we get x all by itself. And that's how we get 1/2. So looking at the end behavior, even degree means it's either going all up or all down. And it's negative, so that means it's going to go all down. And there's stuff that's going to happen in the middle at the zeros, but in general, as x goes to negative infinity, p of x will go to negative infinity as well, since as x is decreasing, y's are also decreasing. And it's the same the other way. As x is increasing, y is still decreasing. So that's the end behavior that happens. On number 14, we have these 3 zeros. And to write a possible factored form representation, I'm just going to go with what might be the simplest one, would be x for that 0, x minus 3 for the positive 3, and then 2x plus 1, which is kind of like how we saw earlier, but just a plus 1. And then 3 different changes. I'm just going to go through and change each one. So starting with the x, something that would still make the polynomial have an x at, or a 0 at 0 would be if this was just a 2x and maybe everything else was the same. That'd be a possible change. If we looked at the second one, we have p of x equals, maybe let's go back to x. Maybe if we did 2x minus 6, that would still give us the same thing. And then the last representation, x minus 3, and maybe if we did x plus 1/2. Just wrote it as the fraction. Those are all possible representations of things that are still equivalent and still give us the same zeros, but are written differently or shown differently. And on number 15, possible polynomials in factored form that could represent these, we got to look at each of our zeros. So I'm going to look at each of one and see how they cross, because that's going to show us the exponent. So at x equals -3, this crosses, and it doesn't cross with a saddle, which is something I'll talk about later, which is right here. So that means this has a multiplicity of 1. At x equals 0, this is going downwards. It bounces, and it's not bouncing with a flatness, it's just bouncing. So this has a multiplicity of 2. And at x equals 5, this is crossing with a saddle, which means that it's going a little bit flatter. So this, I'm going to say, has a multiplicity of 3. And we can see that it has an even degree because it's going upwards on both sides. And it's going to be positive because it's going upwards. So we got to make it positive. So looking at x plus 3, which is this first one, this has a multiplicity of 1, which means this has an exponent of 1. I'm not going to write that. And then for x equals 0, that can just be an x. And since it has a multiplicity of 2, that's an x squared. And then x minus 5, since it's at x equals 5, this has a multiplicity of 3 since it's that cross saddle. And just to double check, we have a degree of 2 plus 1 plus 3, which gives us 6, which is an even degree. And our leading coefficient is a positive number, which means it's going to go all up. Okay, looking at the same thing for the next one. This is at x equals -4. It's just crossing, so the multiplicity is probably just 1. At x equals -2, this is bouncing, but it's not creating a saddle, so the multiplicity, I don't know why I wrote that out, is 2. At x equals 1, it's also a bounce. So the multiplicity is 2 because it's not creating a saddle either there. And then this has an odd degree since it's switching. It's going from increasing on the left side to decreasing on the right side, which means that this is going to have a negative coefficient. And actually, if we look at this constant, this is around negative 25, or maybe I think it's actually negative 32 if I calculate it. But we also can look at that in just a second. So x plus 4 is where one of the zeros was found, and that has a multiplicity of 1 since it just crossed there. X plus 2 is another factor, and that has a multiplicity of 2 since it bounced. And then x minus 1 has a multiplicity of 2 as well. It has a negative leading coefficient since it's decreasing in general. And if we calculate this out and find the constant, right now we have 4 times 4 squared minus, and then times negative 1 squared. So we can see that this is just going to be a negative, but we're not really looking for that. So you can do negative x plus 4 times x plus 2 squared times x minus 1 squared. And that is a possible representation for the factored form.